This is part 2 for the parametric and polar review. Question number 10. Find the speed of the particle whose position is given by x equals 10t plus 4 sine t and y equals 20 minus t, 1 minus cosine t at time 2. Simplest way to do this, I think, is to plug the two equations in y1 and y2. Because the formula for speed is the square root of dx over dt squared plus dy over dt squared. And we need to evaluate those derivatives at our t value, which in this case is 2. So the first thing I would do, now that I have them plugged in, is I can take the derivative at 2. So math 8 allows us to do that. The derivative with respect to x, I'll go to vars, y vars, function y1, and tell it to take the derivative with respect to 2. Now I'm going to store this value in y1, store this value as a. You can store it as whatever letter you want. But that's my derivative of x with respect, or when t equals 2. Let's do the same thing now for the other equation, the y1. Go to vars, y vars, function. We plugged that one into y2. We evaluate it at 2. And we get 14.95. So we do the square, we need to store that before I do that. So store that as b. So now I have my two equations evaluated at their derivative at time 2, and I've stored that as a and b. I can do the square root of a squared. Try that again. Here we go. Square root of a squared plus b squared. And that gives us 17.118. Again, we take the derivative of each equation, plug in t equals 2, and then use the formula for speed. 11. Find the total distance traveled by a particle whose position is given by those equations from time 0 to time 3. Okay, total distance traveled can be found by using the arc length equation. So we will do the integral from 0 to 3 of the square root of the derivative of x, which will be 12 minus 6t squared, plus the derivative of y, which will be 2e to the t minus 5e to the negative t squared dt. If you notice, it's the same thing as the speed equation, but with an integral to go with it. So I will do math 9. I'm going to do the integral from 0 to 3. That's what they instructed us to do. Square root. Be very careful with parentheses here. I need to start a parenthesis and do 12 minus 6t, close the parentheses and square it, plus parentheses 2 e to the x minus 5 e to the x, or negative x, excuse me. Here we go. And we'll square that whole thing. Do it with respect to x. And we find the total distance traveled to be 43.503. Okay, switching gears to polar. Convert the polar point 4 pi over 2 to rectangular form. Let me go ahead and move the calculator over here. The equations we're going to be using to do this are x equals r cosine theta and y equals r sine theta. Because r is this number and theta is this number. So I simply plug in x equals 4 cosine of pi over 2 and y equals 4 sine of pi over 2. And if you know your unit circle, you don't need the calculator. Cosine of pi over 2 is 0. 4 times 0 is 0. Sine of pi over 2 is 1. 4 times 1 is 4. So it turns out that as a polar point, 4 pi over 2 is equivalent to the rectangular point 0, 4. Same process for number 13. We'll use the same equations. X equals r cosine theta, y equals r sine theta. and we have our r and our theta up here. So x equals negative 2 cosine of 7 pi over 4, and y equals negative 2 sine of 7 pi over 4. 7 pi over 4. There we go. Okay. Again, if you know your unit circle, we know that cosine of 7 pi over 4 would be positive square root of 2 over 2. So negative 2 times the square root of 2 over 2 will end up negative square root of 2. And sine of 7 pi over 4 would be negative square root of 2 over 2. So here the negatives cancel, 2's cancel, we get positive square root of 2 over 2, making the ordered pair negative square root of 2, positive square root of 2. Find the area of the region bounded by the polar curve r equals 3 cosine 3 theta on the interval negative pi over 6 to positive pi over 6. Area formula for polar equations is 1/2 times the integral of r squared d theta. So we will do 1/2 times the integral from negative pi over 6 to positive pi over 6 of 3 cosine of 3 theta squared, and plug that in. So 1/2 times math 9, negative pi over 6 to positive pi over 6, do parentheses 3 cosine of 3 theta, close both the parentheses there and square it, and with respect to x, we find that the area is 2.356. Find the area of the region bounded by r equals 1 minus 2 sine theta on the interval pi over 6 to 5 pi over 6. Same formula, 1/2 times the integral from a to b of r squared d theta, 1/2 times the integral from pi over 6 to 5 pi over 6 of 1 minus 2 sine theta squared d theta. So 1/2, math 9, pi over 6 to 5 pi over 6, parentheses 1 minus 2 sine theta squared with respect to x, and we get 0.544. Final problem. Find the arc length of a polar curve, r equals 2 minus 2 cosine theta, from 0 to 2 pi. The equation for arc length looks like this. We do the integral of the square root of the original squared plus the derivative squared. Sorry, my handwriting turned a little messy on that one, but it's r squared plus dr over d theta squared. So our boundaries are from 0 to 2 pi. I'm going to do the square root of 2 minus 2 cosine theta squared plus the derivative of that would be, derivative of 2 is 0, derivative of cosine is negative sine, so it turns into positive 2 sine theta squared d theta. Okay, now again, be very careful with, sorry about that, parentheses. We're going to do math 9 from 0 to 2 pi, square root, parentheses, 2 minus 2 cosine theta, close the parentheses and square it, plus parentheses 2 sine theta and square it, and do dx. And we get 16. Good luck. Make sure you also study the AP questions we reviewed and you know all the formulas you're required to know.